All right, let's dive in. Today, we're going to talk about one of the biggest, most important shifts in modern technology, infrastructure as code. We're going to look at how we went from, manually clicking buttons in a web console to build servers, to defining entire massive data centers in just a few simple text files.
I love this analogy because it just hits the nail on the head. If you've ever tried to perfectly copy a server setup and missed one tiny little step, you know the pain, you know the frustration. Infrastructure as code is all about creating that perfect, repeatable recipe so that your infrastructure is built exactly the same way every single time. No guesswork. So before we can really appreciate just how amazing the solution is, we have to talk about the problem. Let's take a quick look back at the old way of doing things, a world of manual clicks and configuration that, honestly, many of us still remember all too well. Just look at the difference here. The old way, it's all reactive, right? It's logging in, clicking through some wizard, maybe running a one-off script you found somewhere. It's inconsistent. But the new way? It's a proper engineering discipline. You're writing code, you're versioning it, you're automating it. It's a fundamental shift from digital arts and crafts to actual engineering. And all those manual actions, they have some really serious consequences. A simple human error, like picking the wrong server size from a drop-down menu, suddenly your environments don't match. With no documentation, how is anyone supposed to replicate your work or scale it? And with no version history, if something breaks, well, good luck trying to roll back. This isn't just inefficient, it's flat out risky. So out of that chaos, a completely new philosophy started to emerge, one that said we should treat our infrastructure with the same care and discipline that we treat our application code. And that, right there, is infrastructure as code. At its heart, IaC is, well, it's pretty much exactly what it sounds like. We are literally defining everything. Our servers, our networks, our firewalls, our databases, all of it in files that a machine can read. So instead of telling a person what to click, you're telling a machine what to build, and it just does the work for you. These are really the four pillars that make infrastructure as code so powerful. First, it's code, so you can track it in something like Git. It's all driven by automation, which gets rid of human error, and it has this really crucial property called idempotency. Now, that's a fancy word, but we'll break it down in just a second, that guarantees you get consistent results. Okay, this brings us to a really key concept in the whole IaC world. You have to understand the difference between a declarative approach and a procedural one to really get why tools like Terraform are so effective. This is a big one. So here's the best way to think about it. An imperative, or procedural approach, is like giving a chef step-by-step instructions on how to cook a meal. First, you chop the onions. Then you heat the pan to 350 degrees. You're defining the how. A declarative approach is like giving the chef a picture of the final dish and just saying, make me this. You define the what, the end state you want, and you let the tool figure out the best way to get there. It is a way more powerful and resilient way to work. And this right here, this is that superpower I mentioned, idempotency. It's a direct result of that declarative model. What it means is you can run your code once or 100 times, and you will always, always end up with the exact same infrastructure. No accidental extra servers, no weird side effects, just pure, predictable, beautiful consistency. All right, so with that philosophy clear, let's meet the tool that has really become the industry standard for making all of this happen, Terraform. So, Terraform. It was created by a company called HashiCorp. It's open source, and it lets you define all of your infrastructure in a simple, human-readable language. It allows you to manage the entire life cycle of your resources, from creating them to updating them, and eventually to deleting them when you're done. So what makes Terraform so darn powerful? Well, first off, it's cloud agnostic. That means you can use the same skills and workflow for AWS, Azure, Google Cloud, you name it. It uses a really simple declarative language called HCL. Crucially, it keeps track of the state of your infrastructure, so it always knows what it's already built. And with modules, you can create these reusable building blocks, just like functions in a programming language. And that cloud agnostic power, it is massive. I mean, we're not just talking about the big 3 cloud providers. Terraform supports over 1,000 different providers. This means you can manage your cloud servers, your Kubernetes clusters, even your GitHub settings, all from one place with one consistent workflow. It's incredible. And this is the beautifully simple and most importantly safe workflow that Terraform gives you. First, you write your code, Then you initialize it, which just downloads what it needs. Then, and this is the magic step, you run plan to see exactly what Terraform is going to do before it actually does anything. Only when you're happy with that plan do you apply it. It is the ultimate measure twice, cut once for your infrastructure.
So, we've covered the theory and we've covered the tool. Now, let's talk about the real-world payoff. What are the actual benefits that change how teams work every single day? And here it is. The speed is a no-brainer, right? You can spin up 100 servers just as easily as you can spin up one. Reproducibility. This means the end of that classic developer excuse, well, it works on my machine. Now it works everywhere. Every single change is tracked in Git, which gives you a perfect audit trail. And it totally breaks down those old silos, letting developers and operations folks work together on the very same codebase.
And look, this isn't just theory. Teams are using this today to automate their entire cloud deployment process. It's a core piece of CI/CD pipelines. If disaster strikes, you can literally rebuild your entire infrastructure from code in minutes. And you can finally create perfect, identical copies of your development, staging, and production environments. Ultimately, when your infrastructure stops being this fragile, hand-built thing and instead becomes a robust, version-controlled piece of software, everything changes. It just unlocks a whole new level of speed and safety and scale. It fundamentally changes how you think about building things. The question is no longer, can we build it, but what will we build next?